Hi there. In this presentation, we are going to discuss how you can set up a proportion to solve a word problem. If you will turn to page 5 in your red proportion skill drawings booklet, there are 8 questions that are identical to the 8 questions that we will start in this presentation. I welcome you to turn to page 5 and use that as a reference. Use it as a template, if you will. So in our first example, if 64 feet of a rope weigh 20 pounds, how much will 80 feet of the same type of rope weigh? As you notice, we've color-coded the different portions of the 2 ratios that we are going to set up in order to solve the proportion to finally get the answer to the question, how much will 80 feet of rope weigh? If you have 2 different colored highlighters or color pencils or crayons lying around, that might not be a bad idea. It's certainly something we're going to do quite a bit more of tomorrow in class when we look at more of these examples. So I have taken anything dealing with feet and I have made it turquoise, 64 feet and 80 feet. And then I took anything relating to pounds, 20 pounds, and then some unknown amount of pounds. I've taken that and I've made it yellow. This is going to help us set up our proportion. You've heard me say in class that the first step in setting up your unit rate questions is setting it up with words, or setting the ratio up with words. Likewise, the first step in solving this word problem with a proportion is setting up that ratio in words. So what I mean by that is we are going to compare feet to pounds. Our first ratio compares 64 feet to 20 pounds. Notice that feet is on the top of my ratio and I'm comparing that to the number of pounds, which is at the bottom of my ratio. So now 80% of the battle is done. When I set up the second part of that proportion, how much will 80 feet, notice that goes up at the top, of the same type of rope weigh? That's our unknown pound or amount there, which we will represent with an X. Now I can use my property of cross products to set up that one-step equation to solve this word problem. So from here, we're going to identify our diagonals. And we're going to multiply to find our products. So that's 80 times 20 in one diagonal, and 64 times x in our other cross products, or diagonal. We're going to go ahead and use math to simplify what we can. 80 times 20 is 1,600, and we cannot reduce 64x even further. So lastly, our step is to solve for x by division. It's a multiplication equation, and you solve a multiplication equation with division. So we'll divide both sides by 64. 64 divided by itself will reduce to 1, or 1x, and 1,600 divided by 64 is 25. So our unknown value, which in this case represents our pounds, is 25 pounds. Let's look at another example. Our next word problem, which we're going to set up a proportion to solve, reads, if a 10-pound turkey takes 4 hours to cook, how long will it take a 14-pound turkey to cook? Notice again how I have identified my quantities dealing with pounds in one color, turquoise, and my quantities dealing with time, or hours, I have shaded that in yellow. So about 80% of the battle is setting up the proportion correctly. You can go ahead and make sure you do that right by setting up that ratio in words. So our ratio in words is pounds over hours, and you can abbreviate, but please take the time to do this very important step. So 10 pounds is to 4 hours, that's this ratio here, as 14 pounds is to some unknown value, which we will let our variable x represent. And from here, we've got our proportion, and we can use our property of cross products to solve for our unknown value. So we're going to multiply 14 times 4 and 10 times x to set up that one-step multiplication equation. 14 times 4 is 56. And our last step is to divide both sides by 10. And our solution, 56 divided by 10, is 5 6/10 hours. It's always a good idea to go back and make sure your answer makes sense. It does make sense that the turkey will take longer since it's larger. And then, of course, go back and grab a calculator, plug in 5.6 where you see x, do those cross products, make sure that they equal each other. All right, we're going to look at two more examples. Question 3 reads, an 18-ounce box of cereal costs $2.76. How many ounces should a box priced $2.07 contain? So again, I've color-coded my different ratio amounts. I'm going to let the turquoise represent my ounces. Sorry for my typo there. This is supposed to be turquoise. It's pink. And I let yellow represent the amount of money. Set that ratio up in words. Please don't skip this very important step. So we're comparing ounces to cost. So if 18 ounces is $2.76, how many ounces, that's where our x goes, how many ounces, notice x corresponds with ounces, should a box priced at $2.07 cost? Again, notice that the ratio 18 is to 26 as some unknown value is to 207. Our ounces are on the top. Our cost is at the bottom of both ratios. Now we're going to set up our cross products to solve for our unknown value. The best we can get with 2 76/100 times x is 2.7x. And we can go ahead and do that multiplication, 18 times $2.07. That is $37.26. And our last step is to divide both sides by $2.76 to solve for x. And we get x is equal to 13.5 ounces. And again, go ahead and make sure your answer makes sense by plugging it back in. Since the cost is less, we should have fewer ounces in that box. We'll do one more just to be sure. Question 4, again, these are all on page 5. Mike and Pat traveled 392 miles in 7 hours. If they travel at the same rate, how long will it take them to travel 728 miles? Set up that ratio in words. We're comparing miles to hours. So 392 is to 7 hours, as 728 miles is to some unknown amount of time. Set up your cross products. $392x, that's the best we can get because x is our unknown variable. And 728 times 7 is 5,096. We have a one-step equation here to solve. It's multiplication, so we use its inverse, division, to solve. And we get x is equal to 13 hours. There are 4 remaining questions on that page. We will warm up with those tomorrow in class. Please take some time to view these notes, write down any questions so that we can be prepared to discuss them in class when I see you. Have a wonderful afternoon.